so page 33 when we are done. Piecewise functions. I know that you've seen them. You may not have ever heard the name before. You may not have, I know you've seen the graphs. You may not have actually graphed them yourselves before, but I'm quite sure when you first start talking about domain and range and that sort of thing that you've seen some of these, but maybe not graphed them. It depends. Sometimes it happens in Algebra 2, sometimes it doesn't, so it's hard to say. All right, so let's talk about what piecewise functions are. They are functions defined by two or more subfunctions each with their own domain. So they are functions defined by two or more subfunctions, each with their own domain. So if you look at what we have here, we have f of x, which tells us we have a function. Then you have this squiggly bracket, and there's three subfunctions. I have a, what is this? Absolute value. This is quadratic. This is square root, okay? So they don't all get graphed on top of them if we were graphing them, because then it wouldn't be a function, right? We still have to pass the vertical line test. But what's happening here is for everything where x is less than -3, so from negative infinity to -3, I have an absolute value. Then from -3 to 7, it's part of a quadratic. Then from 7 to infinity, it's part of a square root, okay? Does that make sense? So it's just like little sections of it. So when we go to find each value, for the given one, I'm not going to take this -5 and substitute it in all three of these pieces, because this -5 represents x. And I only have, I have an infinite amount of x's, but -5 only shows up once. And I got to decide which subfunction it applies to based on the domain that they've given us. Now, they've given us the domains in inequality notation, which is fine. We've been using interval, but we got to be able to recognize all of it and do all the different ones. So when I look at f of -5, I have to decide -5 falls in the domain of which of these subfunctions, first, second, or third? First, because -5 is less than -3, right? So it goes in the first one. So that means I'm going to substitute it into this piece. So I'm going to have f of -5. That's equal to 2 times the absolute value of -5 minus 5. So f of -5. Oops. So -5 minus 5 is -10. What's the absolute value of -10? 10 times 2 is 20. Okay? Don't plug it into all three. That doesn't make any sense. We good? Okay. So then B. f of 2. Which subfunction's domain does it fit in? First, second, or third? Second. So I'm going to have f of 2 is equal to -2 squared plus 4 times 2. All right, so 2 squared is 4. Then I make it negative. So that's -4 plus 8 is 4. Yes? Okay, 7 falls into which one? Third. But there's a 7 in both of these. Why do we pick the third? Because it's equal to. It's only actually included in the third one. It's not included here, right? So this is the square root of 2 times 7 plus 6. So 2 times 7 is 14 plus 6. I get the square root of 20. Then I have to simplify my square root. And the square root of 20 simplifies to what? 2 square root of 5. Good. 2 square root of 5. That's a skill that you learn in Algebra 1. You do again in geometry, and then again in Algebra 2. Got to be able to simplify your square roots. Any questions at all at this point? We good? Okay, so let's look at number 2. We've got f of x and g of x. So f of x is, what we use a lot, but g of x works, h of x, k of x, r of x, you can use whatever. All right, so we have g of negative 3. So if I'm going to do g of negative 3, which one, first, second, or third, does that fall into? Second, okay? So negative 3 would fall right here. So what is g of negative 3? 8. No work there at all. Because g of x equals 8, and only 8 between negative 4 and negative 2. Okay. All right, so then g of negative 8, that's the first, good, because it's less than negative 4. So that's 1/2 times negative 8 cubed plus 7. Okay, so in this first term here, when I do negative 8 cubed times 1/2, is that value going to be positive or negative? It's going to be negative, okay? So I know that it's going to be negative. Knowing that, that means that I can just not worry about the sign while I do the rest. So I know that's going to be equal to negative something. So let's talk about how to work smarter, not harder type thing. So that's basically this, right? Which I could cube 8 and then take half of it. There's absolutely nothing wrong with that. But to make it a little easier on myself, half of 8 is 4, and what's 8 times 8? 64. So unless you have the type of brain where you can just look at that and know, and I know there's probably at least 1 or 2 of you in here, that's fine. Don't advertise it, because then people won't like you very much, because they're jealous. But I could do 8 times 8 times 8, know what that is, take half of it. There's nothing wrong with that, but the numbers get bigger, right? Personally, I don't want to do it that way. I'd rather make a little bit more sense, right? And anytime you multiply something by 4, all you have to do is double it and then double it again. So if you multiply 64 by 2, what do you get? You get 128, right? Okay, so you see I just doubled it. That was pretty easy. Now I'm going to take this and I'm going to double it, and you can do it a bit at a time. 2 times 100 is just 200. 2 times 20 is 40. 2 times 8 is 16, so you do get 256. And maybe you don't need to split it up that way. That's fine. You do whatever works for you. But this is negative 256 plus 7. So g of negative 8 is equal to negative 249. We good? Okay. So then we have g of 3.1. Where does that fall? The third one, right? So I get the absolute value of 3.1 minus 4. So what is 3.1 minus 4? Negative 0.9, right? So g of 3.1 is just 0.9. Any questions about that? Everybody understand how to know where things fall? Yes? Okay. So let's look at the graphing of them. All right? So it says to graph each function, then give the domain, range, and identify the location and types of any discontinuities. So quickly, what type of discontinuities could we have? What types are there? Jump, point, and infinite. Very good. Okay. And Daisy, have you been talking about continuity in calculus? Yes. And do you talk about jump, point, and infinite? Yes, we totally do. Okay. I'm going to ask her those types of things because I know a lot of times y'all think that I'm lying or I don't know what I'm talking about, and you're never going to have to know it again. Trust me, you do. And you do a lot. Okay. So here I only have 2 subfunctions here. I'm going to graph these. Okay. You have to know how to do what we've been doing the last couple of days to be able to do this, because we're just taking it a little further. So I have 2 subfunctions here. I have an absolute value and I have a linear. Okay. So I'm just going to draw my little sketches so that I have them. If you need to, it's totally fine to write out your transformations. It's not a bad idea. I'm not going to take the time to do that here, but it's not wrong if you do. I mean, some people want to do that to keep up with it. It's probably not a bad idea, but I'm just not going to do it here. All right, so I know I'm going to do an absolute value, but I'm not going to have an entire thing with 2 arrows on it because I'm only going to use part of it. So before I start using my anchor points, I want to figure out what my end point is. If I have all the x's less than 0, then it's going to go from negative infinity to 0. But I want to know what my y value is at 0. So I'm going to take this 0, and I'm going to substitute it in here. Okay? So 0 plus 3 is 3. Absolute value of 3 is 3. Minus 1 is 2. So I'm going to go to 0, 2, and I'm going to have an open circle because this just says less than 0. It's not equal to. Okay? So now when I go to graph my absolute value, just like you've been doing the last couple days, I just can't graph anything to the right of this point. Everything has to be less than 0. Okay? So I'm going to use my anchor points. I got 0, 0. All that's happening here is I'm going left 3 and down 1. So start at 0, 0, left 3, down 1. Then I can use 1, 1. Then I go left 3, down 1. Then I can use negative 1, 1, left 3, down 1. So those are the only 3 that I need. You should get an idea of what it's going to look like. Use your straight edge. And let's draw that in. But when you draw the right-hand side, you have to stop at that point that you made. This side gets an arrow, and the arrow is very important. That's why yesterday I had to come to some of you and say, make sure you put arrows on the end. Here I have an arrow on one side, but not on the other, because it actually does stop. Okay. Any questions about where any of that came from? We all good? All right, so now I'm going to go to the next section. It's everything greater than or equal to 0, but I need to know what my y value is, so I'll go ahead and put that point in. So I'm going to substitute 0 in. 2 times 0, 0, minus 5, negative 5. So we go to 0, negative 5. That one is a closed circle because it's greater than or equal to. And that's actually my y-intercept, which makes graphing the line very easy. What's my slope? 2. So I'm going to go up 2 over 1. And then I can draw in my line. Any questions about where any of that came from or how I knew to do what I did? Okay, so now I got to look at the domain. And it's the domain. I'm not doing the domain of this piece and then the domain of this piece. Together, those two pieces make up one function. So I need a domain of the entire thing. So I start way out here at negative infinity, right? I'm using all of these x's. I don't use that one, but it gets used here, so it does get used. And then I just keep going all the way to infinity. So this is just negative infinity to infinity. My range, I start down here at what? Negative 5. Then I use all the y values all the way till I get to infinity. Do I include negative 5? Yes, I do. And I go to infinity. Do I have any discontinuities? Yes. What kind? Jump. And then you always give the x value of where that is. So it's jump at x equals 0. Questions? Anything? Okay. Then let's go on to the next one. Here I have two sub-functions again. So I'm going to draw my little sketches. I have a linear and I have a quadratic. The linear little sketch isn't as important as the quadratic, but we can do it, so we have it. Okay, so I'm going to substitute in my first endpoint here. I'm going to take this negative 3. So when you subtract a negative 3, it becomes plus 3. So negative 4 plus 3 is negative 1. So I go to negative 3, negative 1, and that's a closed circle because it's less than or equal to. This is a linear part. I don't have the y-intercept. I mean, I can figure out what the y-intercept is, but I'm not going to be able to graph it because it's everything to the left of it. Well, when you use the slope-intercept to graph a line, it's really just getting you a point, and then you count the slope from it. You can count the slope from any point you have on the line. So I can use this one. Is my slope positive or negative? Negative. So is my line pointing up or is it pointing down? It's pointing down. So it's pointing like this, which means I know it's going to have to be like this, right? And then what is the actual slope of this line? 1. It's negative 1, right? So I'm just going to, since I know it's got to go this way, I'm going to go left 1 and up 1 and get that point right there. And then I can draw in my line, or the part of my line, rather. Okay. Everybody understand how we knew where to stop and what to do here? Okay. So now I'm going to find my other endpoint. I take the negative 3 and I substitute it in here. So negative 3 squared is a positive 9 times negative 1/2 is negative 9/2. If I was going to have to write it down, I would write down negative 9/2. I would not write down the decimal. I definitely wouldn't write down the mixed number. But in order for me to find it on the graph, thinking of it as 4.5 or 4.5, totally acceptable. So I go to negative 3 and then negative 4.5, and that is an open circle. Then I use my anchor points, and I'm going to graph this just like we've been graphing the last couple days. I started 0, 0. I have 2 transformations. I'm going to reflect in the x-axis, and I have a vertical compression. So start at 0, 0. When you reflect on 0, 0, nothing happens. When you compress, nothing happens, so I'm still at 0, 0. So then I can go to 1, 1. So I'm at 1, 1. I reflect in the x-axis. Vertical compression of 1/2, I end up right there. If I were to end up with any points to the left of this blue open circle, I would not get to plot them. Okay, don't get to plot them, even if it's an anchor point. I go to negative 1, 1. I reflect and compress, and I end up right there. I have 2 more I have to do, right? Or at least try. So I go to 2, 4. So let me say again, because I had this question again last period. How do you know what your anchor points are? It's based on the function. That's another reason why it's good to write this down as well. 0, 0 will work for all of them. 1, 1, when I put 1 in here and I square it, I get 1. When I put 2 in here and I square it, I get 4. That's how I know this one is 2, 4 and not 2, 8, because 2, 8 wouldn't make sense. So I go to 2, 4. I reflect in the x-axis. Vertical compression by 1/2. Can I get my last point using symmetry? Yes, so I can just plot this point over here. So I've got my 5 anchor points plotted. Then I just sketch in the part of my parabola that is on this graph. Then it looks like that. Okay. Any questions? Okay. So now we do domain. Is it going to be negative infinity to infinity? Yes, because it takes care of all that. So it's just a negative infinity to infinity. What do you think about the range? Yeah, negative infinity to infinity again. Do I have any discontinuities? Yes. Jump again at what? X equals negative 3. Notice, if you have any discontinuities, it's going to be where things change. Because this is a continuous function, this is a continuous function. So individually, they're continuous. If there's discontinuity, which there doesn't have to be, it would end up here. Okay, good? Questions? Okay. We're going to skip number 5 and go to number 6. Here I have 3 subfunctions. Subdoing that. So I'm going to sketch all these. That first one is linear. Oops. That second, and this is what the parent function looks like. The second one is linear, but it would just be y equals negative 1. Would that be vertical or horizontal? If it's a y equals horizontal. So it's basically going to look like this, and then I have a quadratic. All right, so I'm going to start with my first one, and I'm going to start with the endpoint. Let's take negative 4, substitute it in here. 3 times negative 4 is negative 12 plus 8 is negative 4. So I'm going to go to negative 4, and that's a closed circle. Once again, I don't have the y-intercept, but I do have the slope. My slope is positive, so is this pointing up or is it pointing down? Up, right? So that means the function is going to look like this. So my slope is 3. I would normally go up 3 and over 1, but I don't get to go to the right of that point. So instead, I got to go down 3 and over 1 to get that point right there. And there is the part of my graph. Okay. All right. So then, when I find I have 2 endpoints for this section. The x value is at negative 4 and 2. My y value has to be at negative 1. So I'm going to go to negative 4, negative 1, and that's an open circle. And then I go to 2, negative 1, and that's a closed circle. And then I just connect those because y is negative 1 for all of that. Any questions? All right, so then we've got a quadratic. So I'm going to start with 0, 0 here. I'm going to go to the right 2 and down 5, right? So I'm at 0, 0. I'm going to go to the, sorry. What did I forget to do? My endpoint. Take this negative 2, substitute it in there. I'm sorry, the positive 2. 2 minus 2 is 0, so 0 minus 5. So I'll be at 2, negative 5. And that is open. Right? Okay, so now, put my pencil at 0, 0. I'm going to go to the right 2 and down 5. And I have that open circle there. So that is a part of it, but I don't get to color it in just because that was an anchor point. That's just, it's already there, so it's already there. So now I'm going to go to 1, 1. Go to 1, 1. I'm going to go to the right 2, and I'm going to go down 5. And I make that point. My next anchor point is at negative 1, 1. I go to the right 2, and I go down 5. Do I get to plot that point? No, because it's to the left of my open circle, right? So what I can tell from my parabola that I have is that since I'm just moving to the right and down, if I don't get to use this point, I'm not going to get to use this point up here either, right? So I can just have one more, that 2, 4. Then I can go to the right 2, down 5, and I only get the right-hand side of this parabola. Any questions on how we got the pieces? All right. So my domain. Am I going to use everything from negative infinity to infinity? Yes, that all gets used. What about my range? Yes, negative infinity to infinity, they all get taken care of. Even though there's an open circle here, so I don't get to use that y value, it gets used over here, so they all get used. It's negative infinity to infinity. How many discontinuities do I have? 2, and they're both jump, right? So I have jump at x equals negative 4 and x equals 2. And that's, again, see, this is where things change. And if you, it doesn't guarantee that you'll have discontinuity, but if you do, that's where it would be. Okay. Any questions at all? All right, last one. I have 3 subfunctions again. So I've got y equals 7, which is a horizontal line. I've got a cubic, and I've got a square root. So I'm going to start with my endpoints. My endpoint's negative 1 when y equals 7. So I go to negative 1, 7. and that is an open circle. And I'm going to have a y value of 7 for everything less than 1. So then I just draw that in. Make sure I put my arrow on the end to show continuity there. Then I have 2 endpoints here. So I'm going to take my negative 1. I substitute it in there. What's negative 1 cubed? Negative 1. Then I minus 1, so that's negative 2. So I'm going to go negative 1, negative 2, and that's closed. Right? Then I take the 2 and substitute it in. 2 cubed is 8, minus 1 is 7. So I'm going to go to 2, 7, and that's closed. Okay, so I have the 2 endpoints. So when I sketch in, or when I draw in my cubic, I'm not going to have arrows on the end because I'm just going to have a part of it, right? And both of these arrows get chopped off. Okay, so I'm going to start with my anchor points. I'm going to start with 0, 0. I put my pencil there. The only thing that's happening is I go down 1. Boom, I can plot that point. Then I'm going to use 1, 1. I put my pencil there. The only thing that's happening is I go down 1. I can plot that point. Then I have negative 1, negative 1. Put my pencil there, go down 1. Well, that's my other endpoint, right? Okay, so then I use 2, 8. So I go to 2, 8, then I go down 1. That's that endpoint. Do I even need to try negative 2, negative 8? No, because if I do that, I mean, I'm here, and I go down 1, but I don't get to plot that point because it's to the left of this, and it has to be in between the two. Okay? So then this is what I have. I just sketch in that little shape there. Then I'll move on to my last section. Everybody with me so far? All right, so now I'm going to take this 2, and I'm going to substitute it in here. 2 times 2 is 4. Square root of 4 is 2. So I get negative 2 plus 1 is negative 1. So I go to 2, negative 1, and that's an open circle. Okay, so I have 3 transformations here. I have a reflection in the x-axis. I have a horizontal compression, and I go up 1. So I'm going to start at 0, 0. At 0, 0, the compression and the reflection, nothing happens. I just go up 1. Do I get to plot that point? No, I do not. Okay, so then I go to 1, 1. 1, 1. I reflect in the x-axis. Then I have a horizontal compression of 1/2. Then I go up 1. Do I get to plot that point? No. So then my next one is 4, 2. So I'm going to go to 4, 2. I reflect in the x-axis, horizontal compression by 1/2. I think I did a vertical compression on the other one, but it wouldn't work anyway. Horizontal compression by 1/2, and then I go up 1. So that is that point, but it's got to stay as an open circle. Now, I've used all 3 of my anchor points. That 1 point is not enough for me to sketch in my graph. So I'm going to have to use another one. What would be the next x value that would give me a decent y value? Close. 9, 3. But yes. So I use x value of 9 and go to 3, right? Because it's a square root. So 9's off the graph, but that's okay. So I'm going to go to 9, 3, right? I'm like right here. I reflect in the x-axis, so I'm down here. I have a horizontal compression of 1/2, so that means it becomes 9/2, which again is what I'd write down if I had to write it, but 4.5 is going to help me find it on the graph. So I'm at negative, so I'll go 1, 2, 3, 4.5, negative 3. Oops, I don't want to actually make that point. I'm here, and then I go up 1. So knowing what the square root function looks like, are those 2 points enough for me to get an idea of the graph in there? It's fine, but that 1 by itself would not have been enough. So it looks like that. Okay. Any questions about any of that? Okay. So then I'm going to do my domain and range. My domain, am I going from negative infinity to infinity? Start out here at negative infinity. I use all of these x and keep going to infinity, right? So this one does do negative infinity to infinity. Do you understand why? Because somebody said no. Okay. Okay. So I start out here at negative infinity. All of these x's get used. Keep going, all the x's get used, right? My range, do I start at negative infinity? Yes. Do I go all the way to infinity? No. Where do I stop? 7. Good. So it's negative infinity to 7. Do I include 7? Yes, because there's an infinite amount of 7s on there, right? And then once again, I have jump discontinuity at x equals negative 1 and x equals 2. What questions do you have? Okay, good deal. Then go ahead and get this taped in and get started on your delta math for this so that you can practice this some before you actually graph tomorrow.